Okay, welcome to lecture 8.2. So now we're looking at graphs of the polar curves. Okay, so now we're focusing on the polar coordinates. Example 1, graph the polar equation r equals 4. And then we're going to answer, is r equals negative 4 a different graph? Alright, so let's go ahead and try and graph this. So we know for polar that it's r theta, right? So let's go ahead and set up our table for r theta. Well, for our equation, we know that r is equal to 4. But what is the theta value? You know what? There is no actual defined theta value. So the answer is actually going to be theta will be anything, and our radius will always be 4. So no matter what value I pick for theta, my radius is always going to be 4. So let's go ahead and find that on our graph. Starting from the center, you'll have to go out 1, 2, 3, 4. And basically, no matter which theta I pick, we go ahead and have our radius of 4. Let me make sure that I actually put these all on the right spot. Yeah, and then let's go ahead and draw this in. So I might not get the best circle going, but I'm going to give it the best shot. Alright, and there we go. So we have a circle. Interesting. Well, if you remember, if we squared both sides on this equation, we would get r squared equals 16. And r squared is the same thing as x squared plus y squared, which would be equal to 16. And if you recall, x squared plus y squared is the equation of a circle, so this does actually end up making some sense. Okay, and then the question is, if we had r of negative 4, would that be a different graph? So let's go ahead and see what would happen if we looked at r of equal to negative 4. So if we had negative 4 for theta equals 0, it wouldn't matter actually. No matter which item we picked for negative 4, it doesn't matter which our theta is. The only difference is that we would start graphing out in the opposite direction, but we would still have a radius of negative 4, or in our case, 4. So actually no, the answer is it would not graph a different item. Oops, that circle kind of went off there. The answer is no, it is actually the same graph. It is the same graph. Okay, so let's take a look at example 2. Graph the polar equation theta equals 4 pi over 3. So let's see. Let's go ahead and draw a table for r and theta. So for theta, we have 4 pi over 3. But notice there is no radius value given. This is going to be the exact opposite of example 1. In this case, it doesn't matter at all what our radius is. It could be 0, or 1, or 2, or even going the opposite direction, negative 1. We're still going to be at 4 pi over 3. So at 4 pi over 3, which is right here, we know at 0 it's 4 pi over 3, 1 is 4 pi over 3, 2, even so on this direction, and then also it's even on in the negative direction for 4 pi over 3. We go back this way, and this way. So in fact, what do we end up with? We end up with a line. We get a line when we only have theta. And we get a circle when we only have r. Okay, interesting. So now let's take a look at example 3. Graph the polar equation r equals 3 cosine of theta, and then check by calculator. Okay, so for 3 cosine theta, let's go ahead and set up our r theta table. Now I'm going to set it up a little differently. I'm going to go ahead and set the theta values here, and then our r values down in the denominator, or not the denominator, bottom. And then let's go ahead and pick our theta values. So we'll go with 0, pi over 6, just all of the known ones, pi over 4. I'm going to go ahead, pause the video, and fill this out. Okay, so I filled that out. Now let's go ahead and calculate the corresponding values with each of the angles for theta. So, let's see. For the first one, we're going to have 3 times cosine of 0. Now 3 times cosine of 0, that's going to end up being 3, because cosine of 0 is 1. That'll be 3 times 1, so we get 3. So let's graph that. We get 0, 3. 1, 2, 3. Next we have pi over 6, so it'll be 3 cosine of pi over 6. Sorry, it's a little squishy. Now 3 cosine of pi over 6, that's going to be 3 times root 3 over 2, which is going to come out to approximately 2.6. Let me go ahead and just extend all of these down for our calculation purposes. Okay, so about 2.6. So pi over 6, it comes down a teeny bit to about a little less than 3. Alright, I'm going to go ahead and calculate these out and check back in with me in a second. Alright, so I went ahead and I calculated the values and I found out all of the answers. So I'm going to go ahead, once again, remember, any approximations that we do are just for graphing. So the ones that have the approximation symbols, for example, these ones right here, you would never answer with the approximation, you would always answer with the actual value. But once again, when you're graphing, you can make approximations. Okay, so plotting these points, what would we get? Well, we already did the first two. So now the second one, we would have pi over 4, 2.1. So about there for pi over 4. Next, for pi over 3, we have about 1.5. So 1.5 right there. And then for pi over 2, we have 0. Right there for pi over 2. And then for 2 pi over 3, we're going to be at negative 1.5. Well, 2 pi over 3 is here, but we're going to go back 1.5. So we'll actually go in this direction, 1.5. And then we have 3 pi over 4. Okay, so 3 pi over 4 is right here. And then we're going to go back negative 2.1. So negative 2.1, about there. And then we have 5 pi over 6, which is going to be right here. But we're going to go back negative 2.6. So almost at 3. And then lastly, for pi, and we could continue doing this, but for pi, we're going to end up at negative 3. So pi, but we'll go straight back to negative 3, which will end up right here. So if you look at your calculator, when you graph this in, you're actually going to end up with this continual little loop that just keeps going back and forth around here, no matter how high in the pi values you go. And that right there is the graph of 3 cosine of theta. So basically, if you want to know how many of the radians should I graph, the answer would be either you are given the directions or you graph as long as you need to until the pattern stops forming. Alright, example 4. Graph the polar equation r equals 2 minus 2 sine of theta and check by calculator. Alright, so let's see. We'll go ahead, start with our table. Let me change the color to black. We'll get theta and then our r values. Alright, so I went ahead and put in some values for theta that we're going to use, and we may use all of them or we may not. It depends on if the pattern starts repeating itself. So let's take a look. When we calculate these out with our calculator, we'll end up with, I'm going to start the first two, and then after that, just go ahead and realign your calculator, so that'll be 2 sine of pi over 6. And I'll go ahead and fill in the rest of them, and then put down the calculated answers. So that would equal 1. Okay, so I've inputted all the values. So now plugging these into our calculator, what would we get? Well, that is going to be about 2.6, or we'll go ahead and round up to 0.3. Once again, for graphing, you just need to go ahead and show the approximations, and then, oh, that's actually not going to be an approximation. The next one will be 0, about 0.3, 1, 2, 3, and then about 3.7 and about 3.4. Okay, so let's go ahead and graph these, and let's see if we need anything else. We might need a few more theta. Okay, so graphing this, when we have, for this example, just go ahead and we're not going to look at this graph at this time. Let's take a look at the polar graph. Alright, so when graphing this, when we have theta is pi over 6, r is 1. So pi over 6, r is equal to 1. And then at pi over 3, r is equal to 0.3. So really, really small down here somewhere. Then at pi over 2, it's equal to 0. At 2 pi over 3, we go back up to 0.3, about there. 5 pi over 6, it goes up to 1. And then pi, it goes to 2. 1, 2. 7 pi over 6, what does it go to? It goes to 3. 1, 2, 3. And then 4 pi over 3, we go to 3.7. So 3.7 about there. And 3 pi over 2, what do we get to? We get to 3.4. 1, 2, 3.4. About there. And then, as we go on, we're going to notice the pattern will go back exactly the other direction. And we'll end up with a sort of little heart-shaped value. So you might be wondering, well, how will I know how many items or thetas I need to graph in before I know if I'm done? And the answer for that will be, more than likely, on the exam, I'll state the number of points I would like you to graph, and then you can always just check by calculator to make sure that you have the right graph down. And there we go, we get that weird little sort of heart-shaped leaf for sine. Kind of cute. Now let's take a look at example 5. Graph the polar equation r equals sine 3 of theta. Check by calculator. Okay, once again, let's go ahead and set up with our theta and sine. Sorry, our theta and r. Now the question is, which theta value should we pick? Well, if you'll notice here, our theta is actually doubled. So this is, or not doubled, sorry, it's times 3. So in order to pick values for theta that we can find the answers to, we'll go ahead and pick numbers that can cancel with that 3. For example, well, the 0 times 3, that'll end up just giving us sine of 0, which we know is 0. Let's pick, if we picked pi over 12, pi over 12 times that 3, we would get 3 times the pi over 12, which would simplify into pi over 4, which we know the answer to for calculating. We'll get sine of pi over 4, which is going to equal the root 2 over 2, which we know is approximately equal to about 0.7. Okay, and then let's see another one we could pick, pi over 6. That would end up giving us, when we have 3 times pi over 6, we'll get pi over 3. And sine of pi over 3 is 0. Okay, we'll just keep picking values that we could go ahead and simplify with that 3 times theta. And just slowly give us a few more values to work with. So let's plug in these ones. And then if we need any more, we'll go back and fill in a few more. Once again, pi over 12 will give us that pi over 4 when it cancels with the 3 times theta. And then we'll end up with approximately equal to negative 0.7. And let's see, so then we could do 2 pi over 3, which would give us 0. And let's go ahead and work with graphing these now. So if you notice, all of the items are 1 or smaller for the radius. So what we're going to do is we're going to change the tick marks here. Let's go ahead and make 1, 2, 3 up to be our 1 value. So let's go ahead and change that. That'll be 1 mark, and then all the way out will be 2 mark. So now let's start graphing. At 0, we're going to stay at 0, okay? And then at pi over 12, what is pi over 12? Well, pi over 12 is half of pi over 6, so it's right here. That's going to be almost 1, so 0.7. So about there. And then at pi over 6, it's going to be equal to 1. So boop. And then 5 pi over 12, it's going to be negative 0.7. So where is 5 pi over 12? 5 pi over 12 is about here. But we are going to go back to negative 0.7. So follow that along. Negative 0.7 is about here. And then at pi over 2, we're going to go back to 1, right up here. Once again, we start at pi over 2, but we're going to go that opposite direction because it's a negative. And then at 7 pi over 2, so 7 pi over 12. 7 pi over 12 is about here. We're going to go back negative 0.2. So that will be right there. And at 2 pi over 3, which is right here, we're going to be at 0 again. Boop. So, you usually would not be asked to graph more than about 5 or 6, or at least not list more than 5 or 6 points for r and theta. After that, you can use your calculator to assist with drawing out the rest of the diagram, or the rest of the graph. So what we would have is, it's going to actually end up looking something like this when you plop it into your calculator. It'll give you something like sort of a propeller piece on an airplane. Kind of interesting. Isn't it interesting how it ends up graphing this on a calculator? But that's pretty much what you would get if you plop that into a calculator. Once again, make sure to compare that on your calculator, and if you're having any trouble with graphing on your calculator, please just send me an email and we can try work it out together. Alright, so now let's take a look at the last example. Example 6. Graph the polar equation r equals cosine of 2 theta. So this is pretty similar to the one we kind of just did, except this time we have a doubling of theta. So let's go ahead and pick some points for r and theta that will work for cosine times 2 theta. Once again, you're not going to have to rely entirely on picking your r and theta values for graphing. You can use your calculator. However, you will be expected to list out a few of the points, so you want to make sure that you know how to plug in values. Alright, so if I pick 0, that'll just be cosine of 0, which is 0. And then when we have cosine of, let's pick pi. What's cosine of 2 pi? Once again, how did I get the 2 pi? Well, when I plug in pi for theta, we'll get cosine of 2 times pi, which is cosine of 2 pi. And then cosine of 2 pi is going to be equal to 1. Let's go ahead and do pi over 6. So that'll give me a half. And then pi over 4 will give me a 0. And let's just go ahead and plop along all the different values here. So 0.5, plug in these into our calculator, pi over 2, negative 1. For now, let's stop here and see what we get. Okay, so, when theta is 0, we're going to be at 0. When theta is pi, we're going to be at 1. So I'm going to go ahead and change the tick marks here like I did previously. I'll make 3 out to be 1. Okay, so for pi, it's going to be positive 1 right there. Sorry, that should not have been a negative 1. Boop. Okay, so we'll be at pi 1. And then pi over 6 will be a half. So pi over 6 will be at a half. So half of that is about there. And then pi over 4 will be back at 0. So pi over 4, back at 0. Pi over 3 will be at 0.5. Once again, 0.5. Oh, that's supposed to be a negative 0.5. So back this way. About there. And then at pi over 2 will be negative 1. So down here. Okay, and then when you go ahead and plug this into your calculator, you see that it'll start creating sort of a nice little flower piece. And then we go ahead, I'm just going to be sort of generally creating what it'll look like over here. These are not exact points for the rest of them. And then it'll be something around here and here. And we'll get that. So just trying to copy the graph. You'll get sort of a little flower petal thing. So once again, as mentioned before, you'll be told how many points you need to graph. And for that many number of points, you'll need to give an exact answer and show that in the table. And then the rest of the graph, you can just go ahead and fill in by plugging it into your calculator. Alright, and make sure to review the different polar graphs in your book. Other than that, that is it for 8.2. Please email me if you need any help with your calculator or any help with any of the examples in this section or on your homework.